Right, it's recording. Okay. So basically what we're saying here is in your cases, even if you're not working for them now, you'll end up working for a giant multinational corporation, right? Digital is one. We have regional presence across a lot of different countries. And you have Fujitsu, Flow, even TSTT outsources a lot of its stuff. So basically, you're not going to be the only engineer or the only technician working on a piece of equipment. You might be working next to people in India, in the Philippines, in the US, in Europe somewhere. You'll have engineers all over the world. And it becomes very difficult when all of you all are logging into this single piece of equipment or these hundreds of equipment, and you're trying to maintain a consistent template across all of these devices. So maybe sometime in the future, we'll have these perfectly automated systems, but that all controlled by Cisco DNA Center or by a single controller. But from now till then, we need to find some way to better manage these configurations, right? Rather than maintaining a template in Google Docs or a Word document and copy and paste it. So that's what these configuration management tools will help us do. They help us sort of partially automate this manual configuration process and helping us push out these manual configs to different devices. So over time, as engineers have recognized the need for standardization, many have tried to introduce their own templates, master configurations, and configuration monitoring solutions. For example, one simple solution could be to copy and paste the output of the show run command from one Cisco router, then mark the bits of code that need to be changed in the router, for example, interface names and IP addresses. Obviously, this solution is still very error-prone and time-consuming. So this is what you could do, right? You're not going to use Telnet, you use SSH, of course. But you just do a show run, copy and paste all of these stuff, and then you either put in italics or you put in bold, like this. So you're going to change your host name. So you put this word income in brackets, or in italics, or in bold, or whatever it is. This enable password, we know we don't need that. Enable secret 5, and well, they can't really put in the encrypted version of this, but you'll put in the actual command to get it. And all the IP addresses and everything. So you leave the command and you put in the bit that needs to change in a special mark, either italics or brackets or whatever it is. But of course, this is still error prone, right? You realize as you try copy and pasting these things, it never pastes perfectly. If you copy and paste this entire thing and you just paste it back into the same terminal, the terminal never seems to accept the commands one-to-one. You'll always have to go in and recheck everything you're doing, because you'll have some command that depends on another command and it'll miss something. So this is better than trying to retype everything, but it's still error prone. So however, modern configuration management tools have further evolved this same idea by allowing you to create one template file and simply designated certain pieces of the templates as variables. This allows you to set the values for the variables before pushing the configuration out to the devices. So remember, we mentioned variables in the last class. We said that variables were just small bits of memory that could store something. So what if that something was our host name, or our IP address, or our interface description, or our banner, whatever it is? We just store those values in the variables, and then we push them out to the devices so that we could populate this entire config on the router or the switch itself, and all these values are just stored in variables. So this is what we're talking about here, right? You're reading kind of wrong side here, from right to left. So we have this, which is a template, like a master template for a branch router. So in a very simplistic way, think of this template as the output of a show run command, and you have this in a Word document. So we took out all of the places that have specific bits of information, like on branch router 21, we might have the host name as BR21. We took all that in the template. In branch router 22, we had the host name as BR22. We took all that in the template. And same thing with the IP addresses and the interface names and everything. We took out those things from the template and we kind of left them blank, or we left them as template variables to be inserted. So we have that template, And then when the template passes through here, we have this process that will insert those variables into that template. So all of those missing places where we have like hostname blank, this process, so this part of the process will populate that and say hostname BR21, hostname BR22, hostname BR23. And then when we finish populating that, we have the ideal configuration for that branch router. So we have this master template, and now we pass it through this process or this stage in the process where everything will get populated with the correct values from these variables. And then we have that ideal template, that ideal configuration based on that template. So that configuration will be basically identical across all our branch routers, except that those values that's specific to the routers will change. Because obviously we can't have all the branch routers with exactly the same host name and exactly the same IP addresses. We need this variables or this change in phase to change out those specific bits of information. But we want the overall structure to stay the same. So in addition to the templates and the variable files, these tools often include other files that add more flexibility into the tool. For example, many tools allow you to define which hosts you want to push the configurations to and how to schedule actions to interact with those hosts. For example, you could schedule a configuration change and a reboot to take place during the night automatically. So this whole action, maybe we only want to do it to branch 23, or maybe you only want to do it to branch 21, 22, and 23, and all other branch routers from 1 to 20 need to be unaffected. And because you can't mess with this during the day and cause a network outage, because it'll obviously result in some lost revenue, you need to do this during the night. So as long as you trust the system and you know exactly the change you're going to make, you could schedule this whole process to take place on these 3 routers during the night without having to wake up 12 o'clock and do your work and do your checks and then try to go back to sleep. Because that's a very common thing right now. For all network engineers. If you want to do anything on the network, you need to wake out in the night and you need to do your changes and then do your checks and check in with a bunch of people and then try to go back to sleep. So with these tools, you could potentially avoid that because everything will just be scripted. So this is what we're talking about here, right? We have this thing called the config management tool, and we're going to take our subset of hosts. So whatever host machines we want to change or we want to affect, we put in that into our actions and program. So whatever tool we're using, we specify that somehow in that program. We also specify the template, so we know the master template that we want to change and, well, that we don't want to change, sorry. That is the overall configuration of these hosts. So that's the template of the entire configuration. And then we put in the variables. So maybe this will be what we change in. So we want to change our IP address or host name or interface description. We just put in this variable into the tool, and then the tool could automatically schedule or automatically push out that configuration to these hosts without us having to directly SSH into these devices and change it manually. So there are a number of different configuration management tools available today, but Cisco has chosen 3 of the most well-known tools to focus on: Ansible, Puppet, and Chef. So these words are just configuration management tools. They are examples of configuration management tools. Just like Cisco is an example of a network equipment manufacturer, and you have Juniper and Microtech and HP and a bunch of other guys who make network equipment as well. These guys make network config management tools. So they are brands like Cisco. So Ansible is an application that can be downloaded freely and installed on a Mac, a Linux, or a Windows VM, or a main host machine. There's also a paid version of Ansible called Ansible Tower. After Ansible is installed, you must create and configure several text files, such as playbooks. So playbooks provide actions and logics, telling Ansible what it should do. You also have to create an inventory, which provides information about the devices that we wish Ansible to manage. You must also create your templates, which represent the master configuration file for devices. And lastly, you must create your variables, which list the parts of the configuration template that we wish to change on each host machine. So this kind of lines up exactly with the overall structure we were just talking about, right? So the tools may call them different things. A template might not be called a template, but the concepts will stay the same. So we might have, okay, now, here. So for example, this is a configuration of an Ansible template snippet, which is written in a language called Ginger 2. So you see hostname, and then we had the blank, right? Remember I said we're going to put in a hostname on each of these devices, but the hostname will change. So this is how you're going to visualize it now. This bit highlighted in green will be a variable, and that's what's going to change between all the devices. So this part never going to change, but this part is going to change. Similarly, interface gigabit Ethernet 00, this is going to become constant, right? All the routers of this model will have an interface gigabit Ethernet 00. But what's going to change is the actual IP address on that interface. So the address and the mask will be variables, and the tool will insert these variables into the template. Just similar to IP OSPF and the OSPF process ID and the area. If you want to change the area, that is a variable as well. And similar, if we want to put IP addresses here, we just put the commands in the template and we insert the variables as like address2. Or we could rename this to address GE00. And then this one could be address GE01. Just as long as it makes sense and you know where that variable is going to be substituted. Right, so I hope this is making sense so far. This is just a template file, and all we're doing is we're going to be pushing this to a bunch of devices, and we're going to be substituting different variables to actually populate these empty fields here. So that was the example of the template snippet, and that was just a language called Ginger 2. And this is the associated variable file. So this is how we actually put in the values of our variables. And this is written in a language called YAML or YAML. So you could look up all these languages and you'll see some more examples of them. But even not knowing anything about Ginger 2, right? We could kind of read this and understand what's going on. And even not knowing anything about YAML, we could read this and we know what's going on, right? So the language is not too particular because different vendors will have different languages. And maybe by the time you get to actually play with these things, they might have a YAML 2 or a Ginger 3. But the point is to understand the concepts. So you see we have our variable names and the values for them. Variable name, value for them. Variable name, value, same thing. So if we were to put in an address2 under this interface, we would obviously need to add address2 here. So see address2, mask2, router ID, area, OSPF PID, and just a general programming tip, make your variable name something useful. So just theoretically, we could put in like temp1 here or variable1 here. We could just name it that. And then here we could just put variable1 and br1. But it makes our life difficult, right? If we don't know what a variable means and where it's supposed to go, because it's named temp1 or variable1, then it's easy to get lost. So when you're writing code, you should always try to write readable code. And this code is readable, right? Because we have a variable called hostname, and we know what the hostname is on our router. So it's very easy to understand what this variable represents. So Ansible uses an agentless architecture, which means that it does not require any special code or packages running on our devices for it to function. Once an engineer configures all of the files we listed earlier, Ansible pushes the configurations to our devices. This push can be done using a regular SSH session or through another means such as netconf. So you have different options in Ansible. It is like a really big enterprise-ready package. It's not a fly-by-night small package. So obviously, I just mentioned in the main features of it. But you can use it using normal SSH sessions. So you could just tell Ansible, this is how you could SSH into this router, but I'm not going to SSH into the router directly. You are going to do it, and I'm going to tell you what to put in the device when you SSH into it. So it's just the process we're changing now, right? For the whole class so far, we've been talking about going into the command line and typing in things manually. available in both a free and a paid version. You will usually come across Puppet installed on Linux servers, with those servers being designated as Puppet masters. Puppet also requires a special set of files for its operations. So it requires something called a manifest, which is a human-readable text file written in a special language defined by Puppet that defines the configuration of the client device. Then we have something called a resource, class, and module, which are special components of the manifest file. The module is the largest component, classes are smaller components, and resources are the smallest component. Then we have templates, which also use a special Puppet-specific language, which is just called the Puppet configuration language, and it allows for the generation of manifests by substituting variables into a template. So you see, the only word here that we kind of recognize is templates, but the idea is the same, right? We still have variables that we push into our template that is going to automate our configuration of our device. So we just have this new term called a manifest, and in the manifest we have these resources and classes and modules. So the idea is the same, it's just that the implementation is a bit different. So Puppet uses an agent-based model, which means that special code needs to be installed on devices before they can be configured. External agents also can be utilized to support devices which cannot run this specialized code, like many Cisco devices. So unlike Ansible, which was an agentless system, Puppet is an agent-based system, which means you basically need to go into a device and install something. So for anybody who ever did like a sudo apt-get upgrade or apt-get install or anything on a Linux device, with an agent-based model, you would need to do something like a sudo apt-get install Puppet or Puppet client. Or like in the Windows world, you would need to download a file and double click and run the executable file on your machine. And obviously in Cisco, because it's so locked down and it's so secure, we can't just go on and install our own packages or our own programs on the device. So we could utilize something called an external agent to kind of act as an intermediary to support these devices which cannot run specialized code. So Puppet also uses a pull-based model as opposed to push-based, which means that the Puppet agent is responsible for pulling the manifest file and updating the device's configuration to match the requirements of the manifest. So this is what we're talking about, right? So you have this Puppet master, which is that server that we said is usually a Linux server, and you have a special bit of software installed, and he has this manifest file. So we have this external agent, and we have certain ones with the internal agent. So like if this is not a Cisco router, if it's like a I don't know if any vendors, I think Juniper could do it. They allow you to go down to the shell level. So just like we SSH into the router, you could SSH into the router and get a basic Linux shell. And you might be able to install software there. I've never tried it, but certainly some vendors do allow you to install third-party and custom packages. So if this router allows you to do that, you could go in and install this custom Puppet agent, and then that agent could pull this manifest from the Puppet master and figure out, you know, hey, this manifest newer, or this manifest has been updated as compared to the manifest I had last time. So therefore, I need to pull this new configuration. It says a pull-based model. So this R1 would use that agent and pull this manifest and then pull configs if it realizes something changed. Whereas R2, because R2 isn't able to install this internal agent, it needs to SSH to the external agent, or the external agent could SSH to it. And then this external agent, like a server, would have this agent installed in it, this Puppet client, and then the external agent would compare the manifest here or its own manifest and pull the manifest from here and say, hey, this manifest newer than the one I have. Therefore, I need to pull this manifest and I need to update the configuration on this device using a regular SSH session. So of course, you can see the internal agent is much more efficient here because we don't need to waste a whole server just running this external agent. But as I said, a lot of networking devices just don't have the capabilities to install third-party packages on them. So you need this external agent to act as that intermediary. So this is what it looks like. So you have your manifest being built. which is just us going into the Puppet master and saying, I want to change this configuration. I want to update the host name from R1 to R2, for example. So we would log in to the Puppet master and say, R1 is now going to be R2. Okay, save and build. And then we start the agent on R1. R1 would pull that details from the Puppet master. And then it would say, hey, something in this manifest is updated. Either the template has been updated or the variables here have been updated. In this case, since we update the host name alone, just the variables is updated. But the point is something in the manifest changed. So when the agent on R1 pulls that detail and says, hey, something on this manifest changed, then it would trigger a process, and that process would pull the config and say, hey, something changed here. I need to pull this config. Yeah, so I hope that makes sense. So that was Puppet. And lastly, Chef is another configuration management tool offered as a software package for various OSs. Unlike the other two tools, the company behind Chef actually makes several tools. However, the one that most people likely refer to is Chef Automate. Chef is usually run as a server in a client-server mode, with Chef workstations communicating with the configured Chef server. Chef uses an architecture similar to Puppet, with each Chef node or client requiring an agent to communicate with the Chef server. The agent then monitors the central configuration file on the server and pulls recipes from the server to keep the configuration of its client device in sync. So basically the operation is similar to what we just described with Puppet, right? The naming is obviously different. So people try to be clever and intuitive with these names. So we had the Puppet master, which is kind of, pulling the strings and controlling all of the client devices. And now we have the Chef server, which is serving recipes to a device. You see, it's just different naming schemes, but the idea is the same. So you have the Chef node, the Chef agent or the Chef client monitoring a central configuration file on the server, which is exactly what we had in Puppet with the manifest. So we have a central configuration file, and then once the agent or the client sees that something has changed on that central configuration file, it's going to pull recipes, or it's going to pull that template or that updated configuration to keep its configuration or its client device configuration in sync with that master device. So the implementation is different, but the idea is the same, right? So Chef servers are configured with the following files. They're configured with resources, which are the configuration objects whose state is managed by Chef, which is just the config commands for devices. You have recipes, which is the Chef logic that is applied to resources to determine how to apply them to devices. You have cookbooks, which are sets of recipes about similar work grouped together for simpler management. And you have run lists, which are ordered series of recipes that should be run on a client device. So you see, one of these things here are templates and variables, like we started off with Ansible, but the idea is the same. So note that Chef support on Cisco device is limited, so you will likely come across the other two tools being used more often in the Cisco world. So Cisco wants you to learn about Chef because it will be used, or it is used in the server world a lot, but in the Cisco world, not so much. So this is a comparison of the various terms that we just discussed. So in Ansible, we had the playbook. In Puppet, we had the manifest. And in Chef, we had the recipes and the run lists. This is how we get, or how we communicate to the network device. So in Ansible, we mentioned SSH and netconf. In Puppet and Chef, we have these HTTP REST APIs being used, which is why Cisco devices may not support these as much. Whether it uses an agent-less or an agent-full model or just agent-based model. So Ansible is agentless, which was a big selling point of it, and which is why it could be used easily with Cisco devices, whereas Puppet and Chef need agents, but Puppet could use an intermediary to kind of work with devices that can't support that agent, and then whether it uses a push or pull model. So Ansible uses the push model, whereas Puppet and Chef use the pull model. So this is a nice comparison table in case you're confused about the terms and the differences between them. But all of them are built for the same purpose, which is to manage configurations across a big number of devices, right? So that was configuration management tools. And now we'll go on to the last topic, which is interpreting JSON encoded data. So we've made mention of JavaScript object notation or JSON encoded data before. JSON is just one example of a data serialization language. Other examples include XML and Yang. We'll be focusing mostly on JSON because Cisco specifically identified it in their objectives. So JSON attempts to strike a balance between human readability and machine readability. This means that it should be fairly simple for you to read the output of a JSON object and interpret the data stored there. And in a similar fashion, it will be fairly easy for a machine to read that output and to understand it. And personally, I have used XML and JSON is the better encoded format. It is much easier to read in XML. I have never used Yang, so I'm not too sure how it compares to Yang. But the idea here is all of these are examples of data serialization languages, which are just ways of representing data in an easy to read form, right? So just like you have multiple programming languages on multiple network vendors, you have multiple data serialization languages. And JSON is just one of those languages that we're going to discuss. So let's test the understandability of JSON now. Can you understand the following JSON object? So this is one example of a JSON object called JSON dictionary. And the test is, can you read this and understand it? Right, so chances are high that you could have guessed that the object stores data about network interfaces in two routers, R1 and R2. And this was before you even understood how JSON stores its data. So I hope most of you all were able to decipher something about that, right? So R1 and R2, and then interfaces on both of these routers. So we know we don't know exactly what being stored here, but we know something like R1 and R2, and then interface names on R1 and R2, which is the whole idea behind JSON. You don't have a big long text describing exactly, exactly where router 1 is, what type of router it is, how much power it's using, what's the bandwidth on it. So we don't know any of that, but we know this is R1 and this is something about R1. So it's a simple, easy to read structure. So now let's try to actually understand what we just read. JSON stores its data in key value pairs. So I put the word here purposefully, key, value, meaning that keys are stored before the colons and the values associated with each key are stored after the colon. These keys are used as unique identifiers for variables. Think of them as variable names inside programs. So your key here is kind of a variable name. So that's the part before the colon. Then see here, there's kind of a variable name. So any information or data about R1, so R1 would be our variable name, but in JSON, we don't call them variable names, we call them keys. So R2, key. So that's the bit before the colon. Each JSON object can store multiple key value pairs, with each pair separated by commas. Every JSON object or dictionary is denoted by a pair of curly braces. You see these curly braces here? So curly brace, curly brace. So we know it's one JSON object or one JSON dictionary that we're reading about here. Then you see R1 and then colon, something, something, something. We have no colons here and comma. So this whole thing is one key value pair. This whole thing is another key value pair. So I try to put it in handwriting here just to highlight the points. So you see a curly brackets, curly brackets, key, value, value, value. So you see the colon is what separates it, and we list all the values, well the pairs of key values with commas. So you have key, colon, value, comma, key, colon, value, comma, key, colon, value, and then no comma because this is the last one in the dictionary. Yeah, so I hope that is fairly easy to read and easy to understand. So you just saw a single JSON object because you have a single pair of curly braces containing 3 key value pairs. The values of each key were simple text values or strings. However, we can also store more complicated arrays in keys, which lets us store multiple values to a single key. For example, a router with many interfaces, like we had before. We can also nest JSON objects in other objects. So this is the simplest way we could write it, right? I mean, the simplest JSON object, I guess, could just be one pair of curly braces and then one key and one value. But this is fairly close to that. So you have one JSON object with one pair of curly braces and then 3 key value pairs. And each key only has a single value. So that's fairly simple, right? So now let's go on to something a little more complicated, which is arrays. So arrays are a series of values enclosed in square brackets. So this is an array. So you see that's square bracket, and then you have 3 values, and then a closing square brackets. So notice it is square brackets now, as opposed to curly brackets. So note that the array by itself is lacking keys. We simply have a series of values. So in the real world, let me say we don't know anything about football, right? We have square brackets, and we have 3 random names listed here. We don't know what this data is. This could be data on anything. For all I know, Ronaldo could be a basketball player. So we don't know what this data represents. And that's what the key gives us, right? It gives us some context. It gives us a name to our values or a name for our data. So we simply have a series of values. So let's now put this array into our JSON object to associate our series of values with a particular key. This makes it much easier to read and understand what the series of values means. It also makes it easier to import the values into a program and create variables using the data. So remember I said this key that comes before the values is usually our variable name. So if you want to create a variable and we don't know what this data represents, we might create a crazy variable name, like basketball players equal and this array. And then, we screw up our whole data there. So now we put some context. So you have JSON object with 2 key value pairs. So you see this is one JSON object because we have one pair of curly braces. And then now we have our keys. So we have something here before the colon. So we know this is our keys. And this is favorite players. Not the perfect variable name because it could still be favorite basketball players. So I usually like to put like favorite football players just to be very explicit. But at least we know now these are players of some kind. And these are whoever wrote this code, they are favorite players. So we have favorite players to give some context, and then this is the data after it. So colon, and then a square bracket there, and then you have a list of values in the JSON, in the values section. So you see before we just had one key and one value. So now as saying we could have a JSON array, which is multiple values being listed here. Then we have this comma after. So after we put the values, you just put a comma there and then put another key. Favorite teams, then we put teams here in comma with the square brackets there to say this is an array. So we have one key, multiple values in this array. You see a JSON array, this is the key, and we have 3 values. JSON array, this is the key, and we have 3 values. You can see that. So don't focus on the structure too much. It'll kind of make sense after you read a few more JSON objects, but just try to follow along with the description of the different parts of it. So if you understand up to this point, you likely grasp most of what you need to understand regarding JSON encoded data. However, we made mention of one other type of JSON object before, a nested object. Let's give a quick example of what that looks like. Basically, we create JSON objects with each object holding its own key value pairs as before. Then we create an outer JSON object to hold these other inner objects. So this one will get a bit complicated, right? So remember, every pair of curly braces is a JSON object. So we start off here again. We have a pair of curly braces. So we know we have one JSON object here. Then we look. We have a key here, and then we have curly braces again, not square brackets. This is curly braces now. So now we have an outer JSON object containing 2 inner JSON objects because we have these curly braces here. So you see we have this one outer JSON object with 2 key value pairs, one here, and then we have a comma, and then the next one there. Then on the inside now, we have multiple key value pairs in this key. So you have this key here, you have a next object, and then key value pairs. Again, key, colon value, key colon value, key colon value. And if we wanted to make it more complicated, we could have put square brackets in here and list out multiple players, or put square brackets here and list out multiple teams. So you see, JSON objects could get fairly complicated, and it all depends on what we want to store. Do we want to store a single player or multiple different players? And it all depends on what we need to store in our program. So the idea is just start from the outside, look at the types of brackets, and then you know whether it's a JSON object or is an array, whether it's a single JSON object and it just contains multiple key value pairs, or whether it's a nested object with multiple key value pairs inside another set of key value pairs. So to close, note that your JSON data will likely not look like this in the real world. When you are programming or scripting, your IDE or terminal will likely remove most of this white space. Your actual JSON will thus resemble this. So you have the same curly braces, but you see now we don't have the new line. We don't have key value, comma, and then key value, comma, key value below. It's just going to the side. So if you do a print or a show or echo, depending on what language you're working with, it will just be listed out in a line. So that's why it's important to understand the different symbols and understand how to interpret it. And don't expect it to look in this kind of perfect format all the time, because it won't. It will look like this on the command line. So that's it. That was the end of the official syllabus. So see, we did the configuration management mechanisms, and then we did interpreting JSON encoded data. So that's it. That is all Cisco has asked us to do. So the next thing I want to do in this class is go through this bonus course, which is Cisco Security Best Practices. So I'll just go over some of the security stuff that we discussed and how you can secure your own Cisco devices when that time comes. I think, okay, you can wait on this. So I have a few other things to tell you to do to prep for Thursday. But if you start that now, it might screw up your connection. So let me finish off this, and then we'll do that last. So give me 5 minutes. Take a 5 minutes. This course won't be too long at all. So we'll come back at 6:55, so 5 to 7. And we'll finish off this course, and then I'll let you know what we're doing on Thursday. Okay. Stop.